All right, in this video, we're going to do review number 13. So in number 1, we need to graph the linear function y equals 2x minus 1. And I know that this is a linear function because I don't have a squared term and because my x is associated just with a coefficient and is not an exponent. So I can determine by looking at this function that my slope, my m value, is equal to 2. So that means my slope will be 2 over 1. And my y-intercept, my b term, is equal to a negative 1. So if my b term is equal to a negative 1, I'm going to look at my y-axis here. And there is my negative 1. It's kind of hard to tell now for some reason, but this is my x and y. There is my y-intercept. My b term is negative 1. From there, I'm going to do my slope. So my slope is going to be either 2 over 1, so meaning I'm going to go up 2, 1, 2, and to the right 1. So up and over, up 2 and over 1, up 2 and over 1. Or remember that if I have a positive 2 slope, I can also do negative 2 over negative 1. So that would be down and to the left. So that would look like down 2 and to the left 1, down 2 and to the left 1. So I can graph my line now. And there's my linear function. In number 2, this graph is a quadratic function. And if I'm doing a quadratic function, then the first thing I want to look at is my a term. And if my a term is positive, then I know that I'm opening up. Okay, then I'm going to look at my b term to help me determine my axis of symmetry. And my b term is a positive 4. And my c term is equal to 3. And my c term is going to tell me my y-intercept. So again, I'm going to just redraw my x-axis and y-axis. My y-intercept is a positive 3. 1, 2, 3. There is my y-intercept. This only works when in standard form. If I'm in vertex form, the constant is not my y-intercept. So please be careful with that. All right. So using my b term and my a term that I have here, I can determine my axis of symmetry. I'm just going to put axis. So that's going to be negative 4 divided by 2 times 1. So that's going to equal negative 2. So that means my axis of symmetry is going to pass directly my vertex, directly through my vertex. So now I can create my table to find my other points to graph. Okay, so I'm going to create an x and y table, putting my vertex of negative 2 in the middle. And then to find the y value of my vertex, I'm going to find f of negative 2. And f of negative 2 is going to be equal to negative 2 squared plus 4 times negative 2 plus 3. Well, negative 2 squared is 4. 4 minus 8, right? 4 minus 8 is negative 4, plus 3 is negative 1. So my y value for my vertex is negative 1. So negative 2, negative 1. Here is my vertex. Now I can find another point by finding negative 1. So if I find f of negative 1, then I'm going to have negative 1 squared plus 4 times negative 1 plus 3. Well, negative 1 squared is 1. 1 minus 4 is negative 3. Negative 3 plus 3 is 0. So at negative 1, I'm at 0. Now that I've found that point, I know that that's going to be a reflection. So at -3, I will also be at 0. And I already have my next point because my next point is 0. And when my x is 0, my y was 3. That was my y-intercept. And that's also going to be another reflection point that I can graph for -4. So at -4, I'm at 3. And now I have the 5 points that I need to sketch my graph. So there's my quadratic function. Okay, let's look at our exponential function, number 3. Y equals 2x plus 1. So that's 2 to the x. Sorry, this is an exponential function. And so that plus 1 is going to tell me that that y-intercept is going up by 1. So my y-intercept is going to be at 2. Remember, because f of 0 means that I'm going to have 2 to the 0 power plus 1. Well, anything to the 0 power is 1. When you add 1 to 1, you get 2. So that is my y-intercept. Now to find the other points to graph, I'm going to create an x and y table. Okay, so I already know what 0 is, so I can find -1, 1, and 2. So when I find f of -1, I'm going to have 2 to the -1 power plus 1. Well, 2 to the -1 power is 1/2 plus 1 is equal to 1/2. So at -1, I'm at 1/2. And there's my point. Not negative, sorry. My 0 point we already know is 2. And then I'm going to find f of 1. So that's going to be 2 to the 1 power plus 1, which is equal to 3. So at 1, I'm at 3. And then I can find f of 2. So that's going to be equal to 2 squared plus 1, which is going to be equal to 4 plus 1, which is 5. So 2, 1, 2, 3, 4, 5. There is my next point. And I'm just highlighting these so you can follow along if you want to take a look. Okay, so this will be my exponential function. My asymptote here is equal to a positive 1. It should be 1 and 1/2. Oops. So this y value, because I know my asymptote is equal to y is equal to 1, so this should be 1 and 1/2. So there we go. One and 1/2. Sorry, guys. Crammed for space. So number 4, what are the zeros, the extreme values, the maximum, and symmetry? So we need to know our zeros, which are solutions, our extreme values, which is our max or min, and our axis of symmetry for the function y equals x squared plus 6x plus 8. So remember, your zeros are your solutions. So we're going to take this function and we're going to factor it. And my a times c term is going to be 8x squared. And my c term, my b term is 6x. So the factors that multiply to give me 8 and add to give me 6x are going to be 2x and 4x. Then I'm going to use my area model. Remember, my x squared goes here, my 8 goes here. 2x and 4x will just fill in the empty boxes. Now I just need to factor it out. So I'm going to have x plus 2 and x plus 4. So if x plus 4 multiplied by x plus 2 is equal to 0, then that means x plus 4 will equal 0, or x equals -4. So that's one solution. Or I'm going to have x plus 2 is equal to 0. So x is equal to -2 is the other solution. So those are my solutions. Next, I need to find the extreme values, the max or the min. Okay? And I also need to find my axis of symmetry. So I'm going to start with my axis of symmetry. Remember, to find your axis of symmetry is going to be -b divided by 2a. So I'm going to have -6 divided by 2 times 1, which is going to be -3. So my axis of symmetry is x equals -3. And then to find my max or my min value, which in this case, because my a is positive, my graph is opening up. So I'm going to have a minimum. So let's find our minimum vertex, our vertex for our minimum value. So we're going to find f of -3. So that's going to be -3 squared plus 6 times -3 plus 8. Well, -3 squared is 9. 6 times -3 is -18 plus 8. So I'm going to have 9 minus 10, which is equal to a -1. So my vertex is at -3, -1, and that's going to be my minimum value. What are the zeros, extreme values, max or min, and symmetry for y equals x plus 3 squared minus 4? This equation is given to us in vertex form. And because it's in vertex form, and I know that this is going to be h, and this is k, and my h is going to be the opposite, I know that my vertex is going to be -3, -4. Because my a term is positive, I know that I'm going to be opening up. So this is going to be my minimum value, is -3, -4. To find the zeros of this function, I have to solve for x. So to find my zeros, I'm going to have 0 equals x plus 3 squared minus 4. So I'm going to add 4 to both sides, and I get 4 is equal to x plus 3 squared. Then I need to take the square root of both sides, and I get plus or minus 2 is equal to x plus 3. So now I need to take this whole function and solve it. So I'm going to have x plus 3 is equal to the positive 2. So that means x is equal to a -1. Because all I did was subtract 3 and subtract 3. And then I'm going to have x plus 3 is equal to a -2. When I subtract 3 and subtract 3, x is equal to a -5. So those are my zeros, my solutions. These were, then I already found my extreme value, and then my axis of symmetry, my axis of symmetry is x is equal to a -3 because it's always the x value of my vertex. All right, number 6. Does y equal 1.03 to the power of x represent growth or decay? Well, if this is greater than 1, then I represent growth. And what is the percent rate of change? Well, 0.03 equals 3%. So it's growing at a rate of 3%. Now, number 7 says, does y equal 0.97 to the power of x represent growth or decay? Well, here 0.97 is less than 1. And if it's less than 1, then I'm going to have decay. And I subtracted 0.03 from 1 minus 0.03 to get 97. So that means that I'm decaying at a rate of 3%. What is your percent rate of change? It's decaying at a rate of 3%. All right, number 8 looks something very similar to what we saw in the mock EOC. So this here is called a cubic function because I have 3 x values. So a cubic function is always going to look like that. But all you really need to know here to solve this is the zero product property rule. And the zero product property rule states that if you take one of these values and if you take each one of these values and set it equal to 0, then you'll have your y-intercepts. So you're going to take x plus 1, set it equal to 0, and x is equal to a -1. So that's my first x-intercept. X is equal to -1. So here I look at -1. Well, I don't have an x-intercept, so I can cross out A. -1 here. I'm good. C is a possibility. B has a -1, possible. And D, the graph is not crossing that -1. There is not an x-intercept, so I can cross out D. Now I'm going to look at x minus 3. So if I set x minus 3 equal to 0, then x is equal to a +3. So that's another x-intercept. So if I'm looking for +3, well, here we go. So C is still a possibility, and B is still a possibility, and I've already ruled out A and D. Last, I have x plus 2 is equal to 0. So that means x is equal to a -2. So I need to have a y-intercept at -2. Well, C does not have an x-intercept, is what I meant, an x-intercept at -2. It only has an x-intercept at +2, and that's wrong. Here I have my x-intercept at -2, so my correct answer here is B. Number 9, don't worry about. You're not going to be asked anything like that. Just cross it out. Number 10, at a swimming pool, a child jumps off a diving board. His height in feet, based on time in seconds, is given by the function h of t is equal to 3 plus 12t minus 16t squared. The coordinates for the maximum of the function represents which of the following? So first of all, I would recommend that you always write your function in degree order. So if h of t is equal to a negative 16t squared, because our quadratic function should always come first. That's the term with the highest degree. That exponent is telling me the degree. Then I'm going to write plus 12t. Then I'm going to write plus 3. So this, if my a term is equal to a -1, I know that I'm opening down, and I could determine that because of this word maximum. So envision a boy, a child, jumping off a diving board, going up and then coming down. So what is this maximum value telling you? The maximum is telling me the max height that the child reaches. Okay? It also tells you how long it takes for the boy to reach his max height. If we're talking about the water, then this would be when our x is equal to 0. When y is equal to 0, I mean. This here is when y is equal to 0. So that's not talking about that maximum value. And that height of the diving board, this would be your c term. That's your initial value. So that also is not what the maximum point is telling you, or the vertex is telling you. All right, that's it for EOC review number 13. Let me know if you have any questions in class.